We're going to determine if the series from n equals 1 to infinity of 5 times 2 to the n plus 1 divided by 3 to the n converges or diverges, and if it converges, what does it converge to? So first thing we're going to do is write it in the following form. This is n equals 1 to infinity. Notice that 5 is not raised to any power. 2 to the n plus 1 we're going to rewrite as 2 to the n times 2 to the first divided by 3 to the n. Notice that 2 to the n and 3 to the n are both raised to the same power, so we can combine them into a fraction. This is now summation from 1 to infinity. We'll take the 5 and the 2, that's 10 times 2/3 raised to the nth power. Now this, we could use the formula for a geometric series here, except for the fact that this series starts at 1, not at 0. When a geometric series starts at 1, its standard form should look like this: summation from 1 to infinity, a times r to the n minus 1. And then if we plug in 1, we get a, and then if we plug in 2 for n, we get ar, and so on. Now this will converge to a divided by 1 minus r if r is strictly between -1 and 1. So the next step in our series is to make it look like the standard form. It's not that hard to do. This is summation from 1 to infinity. We take to 10, and then we'll take 2/3 to the n and write it as 2/3 to the first power times 2/3 to the n minus first power. Now 10 times 2/3 is 20/3. So now we can write this as summation from n equals 1 to infinity, 20/3 times 2/3 to n minus 1. And now this is in standard form. All we have to do is recognize a and recognize r. A in this case is 20/3. So a is equal to 20/3, and r is equal to 2/3. Clearly that's less than 1 and greater than -1. Therefore this series is going to converge to a 20/3 divided by 1 minus r. So this is 1 minus 2/3. This is equal to 20/3 divided by 1/3, which is equal to 20. So let's summarize the series given by the summation from n equals 1 to infinity of 5 times 2 to the n plus 1 divided by 3 to the n is a geometric series that converges to 20.